Okay, in this video we're going to use a graph and use tangents to find what's known as the rate of change. When you draw a tangent to a graph, you're finding the rate of change. So in this case it's going to be the rate of change of depth with time in hours. So it's depth in meters in hours. So it says the graph shows the depth d meters of waters in the harbour against t hours during a 24-hour period. Use the graph to estimate the rate of change of depth in meters per hour when t is equal to 2, t is equal to 8, and t is equal to 16. It's actually far easier to do it if you actually know what the function is. So here we have a tidal function. This does map very familiar sort of pattern that we have here in Southampton, where we have a high tide, tide goes out and then the tide comes back again, just for a point of interest, although the timings might not be correct. Okay, so to do that, what we have to do is we have to draw a tangent for part A at t is equal to 2. So here's my graph. So we find t is equal to 2 and we draw a tangent, draw a point at the particular point, here. Okay, and then carefully we take our ruler and then we have to draw a tangent. It's not very easy to do, so you need to be very careful how you do it. So you have to line it up properly. Drawing the tangent and we get our tangent here. Okay, this is not a very accurate way of doing it. Then we need to pick some convenient points on the tangent to find the gradient of the tangent, because it's the gradient of the tangent that's going to give us the rate of change of depth. So I pick this point here, okay, and obviously the point P. Now this point here, what we're going to do is work out what actually one of these little squares is, and it's worth So we'll start at the top. Sorry, we'll work here. This is going to be 14.4. So it's 14, and they're halfway between the next one, so it's going to be in that 0.2 more. So it's going to be 14.6 minus 0.4. One of these squares is 0.4, and it's going to be the same across the horizontal axis as well. This one's quite easy. That gives me 14.2, but this one's quite easy because it gives me 2. So you have to take particular care over the scale. And then we need to do the rate of change of depth is going to be equal to 14.2 divided by 2, and that gives me an answer of 7.1 meters per hour. Okay, notice that the rate of change of depth is positive, therefore the depth is increasing. All right, so if you get a positive rate of change, something's increasing. And then in a minute we'll look what happens when we have a negative rate of change. Okay, for part B, we're going to drawing the tangent at t is equal to 8. So we'll find t is equal to 8. We'll draw a dot there. And then we'll take our ruler, and again we'll line it up the best that we can. It's quite difficult to do. And then we draw our line. Okay, that gives us our tangent, and then we find the gradient. So we're going to take some convenient points. So I took this point here and this point here. You can take whatever point you like. Okay, again taking into account of the scale. So this is going to be, now you have to start at the bottom here because this is a negative gradient. So this is halfway between this one and this one approximately. So it's going to be 0.6 minus 15.2. Okay, so it's 15.2, that's 16.4, 16.8, 15.2. That gives me minus 14.6, minus because we're going downwards. This one we can get by doing 2.8, which is probably better from working out being from 10.8, which is that point there. Take away 8, which gives me 2.8. Okay, the rate of change of the depth will be the rate of change this distance divided by this distance. That's the gradient. So it's minus 14.6 divided by 2.8, which gives me minus 5.2 meters per hour. Again, this one, we notice that the rate of change of depth is negative. Therefore, the depth is decreasing. So the quantity is actually decreasing. That makes sort of sense. Okay, so drawing a tangent now at t is equal to 16. So we find 16, which is there. Put our dot at that particular point there. put our ruler in, draw our tangent. Again, you have to be particularly very careful how you draw the tangent. It's not very accurate. Again, picking some convenient points. Okay, so here this one is 4 because it's quite easy, it's 2 along, and then I'm going to do 14 minus 18.6. This is 18 with halfway between, which is equal to minus 4.6. So the rate of change of depth will be equal to minus 4.6 divided by 4, which gives me minus 1.2 meters per hour. Again, note that the rate of change of depth is negative, therefore the depth is decreasing, but it's decreasing at a lower rate than it was over here when we had t is equal to 8. Now we could just check our answers here. So here we have an applet, GeoGebra applet, and I'll put this link in the notes of the video on YouTube. Okay, so here we have the function, and then if I click here, okay, I can have the tangent. So if we go for 2, we can see that the gradient was 7.25. That's not too far off our actual answer. This is a calculated value using the software. Then we did 8. Okay, we got minus 5.09. Again, it's not too far off what we got. And then we also did A is equal to 16ths, and they give minus 1.13. Okay, so the tangent gives us a rate of change of one quantity and the other. If you're doing like distance time graph, then the tangent, the gradient of the tangent will give you velocity, and if you're doing or speed if you like, and then if you are doing velocity time graph, then the tangent will give you the rate of change of the acceleration. Will give you the actual acceleration at a particular point, the gradient of the tangent, that is. Okay, you can also get the equation of the tangent as well, that might help. Obviously it's far easier better to do it with software, but for the time being we will just look at it just by drawing by freehand. Okay, I hope you've understood. The GeoGebra applets in the notes of the video. I thank you very much for watching.